Okay, so on this video, I want to show you the connection between the two functions that are inverses of each other and what their graphs look like. So all functions and their inverses are symmetric over the line y equals x. So I went ahead and graphed y equals x here. So on the first example I did, I found the inverse of 4x minus 8. So there's the graph of 4x minus 8. And the answer turned out to be 1/4 x plus 2. And so you can see they are reflections over the line y equals x. Okay, it's almost a little bit harder to see with straight lines, but they'll meet here on there. Let's look at some ordered pairs. So you've got the point 0,2 on one graph, and you've got the point 2,0 on another graph. If I pick a point here, I can't really get to stick, but you know, 6, 3.5 is a point. So 3.56 should be a point on the other graph. Okay, so there's 3.56. So that's what inverses do. Here's an example here. I've got -8, 0, and then I should have 0, -8 on the other one. Okay, so that's what inverse functions do, and that's what makes them symmetric over the line y equal x, because the x and y switch places. Okay, so let's look at two other lines. So there's, and let's turn that one off. So here is the line that we were given, and then we found the inverse, and it came out to be -2x minus 3/2, and they are symmetric over the line y equals x also. Okay, again, it looks like we've got the point -5, about 2, and so 2, -5 is about there. Okay, if we turn those two off, we can see something a little more interesting. Let's look at this graph. Okay, so we have that rational function, and then its inverse is this graph. So if you kind of look at the halves of it, this purple piece is a reflection of this green piece, and then this green piece is a reflection of this purple one over the line y equals x. If we turn those off, we can look at this one. So the square root of 4 minus x starts there at 4 and goes back that way. So, you know, it's got the point 0,2 on it. So and the point 4,0. So the other one is going to have the point 0,4 on it and 2,0. So it's going to go through here like that. So if I graph that one, we got 4 minus x squared. Now, if you can see here, I've got x is greater than 0. The x and y change places. So this y is always going to be positive. Okay, let's go back and look at this. Because it's the positive square root, all of the y values are positive. If I wanted the negative ones, I would put a negative there, and that's all the negative square roots, okay? Because a square root could be plus or minus. So if it's y equals the square root, then it's the positive ones. Okay, so those are the positive ones. Well, in the inverse function, the x and y switch places. So if the y is always positive here, the x is going to have to always be positive there. Because if you do that, when you square both sides, we got an x squared. It would have been, you know, without this, it would have been a parabola. And that's not true. So that we need to say x is greater than 0, and that's what gives me this piece of it, so that it is the inverse of this function. It will be a very common thing for me to give you a problem where I don't give you y equals x, and I don't give you the equation at all. I give you something that looks like that, and I say sketch the inverse. And so you need to know that it's a reflection over that line, and that it would start here and go there, and be able to sketch the graph without knowing what the equation is. Okay, so hopefully that helps you understand how the graphs of inverse functions are related to each other.